Hey guys, what's up? This is your friend Mainak from Civil Center and welcome all back to our channel and another video. In today's video, we are going to discuss a very special topic that is column orientation. So we are going to discuss what is column orientation, how does it affect the structural drawing, and also we'll make the column orientation of a given plan. So without wasting any time, let's get started. So basically you are looking at this plan. In this plan, we'll do the column positioning as well as orientation, and we'll discuss how to proceed with the further steps. Okay. So basically let's discuss about column orientation here, and then we can proceed. So you can write this as column orientation. So if you see the columns in the practical field, so it can be square. Just from the layman point of view, it can be square and it can be rectangular. Okay. So these are two types of columns which you see. So if it's square, then it's good. But if it's rectangular, that is the shape of the column will be like this. Then it will have a length and breadth. Length is the larger dimension. So this will be your L. Let me call it L. And this will be your B, the breadth. So the larger dimension and the shorter dimension. So whether this will be horizontal or whether this will be vertical, how can we know that? This is all about the orientation. Suppose we have, I'm making a simple a room here, and we have this particular room, and I am giving my column orientations. Suppose this is one orientation of the column L and B, and this is the another one. Same column, if we rotate this is my another orientation. This is L and this is your B. So let me call this as orientation 1, and let us call this or O1, just O1, and we'll call this as our O2. So here we can just mark this, whether this columns which we'll have here. Suppose we have 4 columns here, 1, 2, 3, and 4. So what will be the the orientation of this, we can check. And in another room, let's say this one, a square room, and what will be the orientation of columns here. So if you check this rectangular room, and you can check this horizontal dimension is lesser than the vertical dimension. So in this column which has the horizontal dimension more, it will not be used. This one will be used. This one vertical dimension is more, so here orientation number 2 will be used. I'm just using some practical examples so that you can have an idea. In this case, this is the case 1. This one also, if you check this dimension, this one is more, so definitely this one will be O2. So in this case, all are O2. I am not using measurements, I'm just using visualization, because in plan you will have the detailed measurements anyway, that is this one is this one is this, but just to have an idea of that, and then we'll also solve it in the practical project as well. Okay, and have a look at this. This is a square. So what will be it? In this square, if there are we have 4 columns here. If we have 4 columns here, like 1, 2, 3, and 4, all these 4 columns will be square, because the load coming from this side and this side is the same. Now when I'm talking about loads, question must come in your mind, why the load coming in this side is the same, and why we will place it in the longer dimension. To have an idea about that, we need to just know about the yield line theory. I'm not going to go in detail about the yield line theory, but basically the yield line theory is a theory in which they talk about the load distribution. You must have studied it in your course, especially if you are taking structural engineering. So suppose this is a slab here, and we have 4 columns maybe. So this is one column, and this is another column, and this is another column, and this is another column. Okay, so let us draw the beams also, because the load of the slab will be transferred to the beams. So just ignore if it is not properly done. I'm just having an idea. So these are the 4 beams which I've drawn, and we have also drawn the 4 columns. So what will be the loads acting on the beams? The loads acting on the beams will be the apart from the self weight, obviously the self weight of the beam, and then the load of the slab, So the load of the slab will basically be the dead weight, dead load, that is the self weight of the slab, and along with it, the live load of acting on the slab. So live load will be, as per the standard codes of your country. If you're using Indian codes, it should be 875 Part 2, in which there are various live load defined for the various usages of the building. So like that, you can define the live loads. So the live loads and dead loads will be acting on the beams and also the load of the your wall surface. Okay, so now in the yield line theory talks about the load distribution from the slab to the columns. Obviously, it will go through the beams to the columns, but it talks about the load distribution from the slab to the columns. Which part of the load is transferred to which columns? So basically, you can just draw something like this, this and this and this. So I'm just making it very easy and simple for you to understand, so that next time when you are going to assign orientation to a column, you find it easy to understand. This 1, 2, 3 and 4. So we have divided into 4 zones. So columns also, I'm just naming this column differently, C1, and then let's name this as C2. Let's give this C2, and let's give this name of C3, and let's give this name of C4. So we have divided this column names. So C1 is going to take the load of portion 1 and portion 4. So we'll just do the 1 plus 4. And then C2 will take the load of your portion 1 and portion 2. So it will be similarly 1 plus portion 2. So you have understood. Similarly, C4 will take the load of this 2 and 3. C3 will take the load of this and this. So like this, the load distribution happens. So if this theory is correct, if we have a larger span like this, and we have 4 columns along the ends, let's give 1 column here, 1 here, and 1 here, and another 1 here. So we have 4 columns like this. Let's also give them names also. Let's see C1, C2, C3, C4. Like this, it will be naming. I'm just we don't need to complete that. C1, C2, C3, C4. Just like this, it will be naming. Now, what will be the loads which will be acting here? Just have a look at that. If I'm just drawing the yield lines, the beams will be there. Let's just ignore the beam for now. So if I draw the yield lines, you can check here. The yield lines will be like this. So if you can observe that the area. So if you find out this area, that is this particular area. If you again, let me just divide this into 1, 2, 3, and 4. So the loads taken by C1 will be less from this one and more from this 4, because obviously the area of 4 is more. So the loads along this particular vertical is more than the loads taken by the horizontal. So that's why we're going to use the orientation. When we'll give the column orientation, we'll use the orientation in which its length is along the vertical. Okay, so if you're going to provide an orientation here, we're going to provide 250 cross 300. So where if you check here, this one will be the 250 and this one will be the 200. That is 250 will be the horizontal dimension and 300 will be the vertical dimension. So why 250 to 350? Because basically when we start along with any project, if we want to give square size, then we generally provide 50 columns. And when we have this, when we want to provide rectangular columns, we start with 250 cross 350, sorry 300, or this is one orientation, or 300 cross 250. So these are the two orientations which we use of the same size. We increase by 50 and 50. And after that, after we increase that, we just put it in the design software, whether it be Tekla Structural Designer or STAAD or any software, put it in that and see whether this is safe or not. If it's safe, then it's good. Otherwise, we will go for the next size. So like that we do, because ultimately we want an economical design. So this is the way in which you can provide the orientation. We can start with 250 into 300. And similarly, I hope you have understood the logic also why the longer dimension is given along the along the longer span. So I hope you have got the concept, and after you have got the concept, let us discuss about the column positioning of this project. So now I will discuss this. So basically, before column positioning, I will tell you some of the requirements of this particular plan. So basically, in the ground floor, we can't give any columns in between. So only for the staircase portion there will be columns, and in between this span we can't give any columns, because in the ground floor it has been used for stilt, and the owner of this building doesn't want any columns. So we'll keep that into consideration, and we'll just assign our columns here. So we'll start our assigning our columns from here. So let's give a column here. This will be our first column, and after we place the columns, we'll then discuss about the orientation. So if we have a video on our column placement, you can watch that, and also we'll discuss some concepts here also. So we have placed one column here, and we look at this span. There is roughly you can look at the span. So it is 10 feet 6 inches and 5. So it is around 15 feet 6 inches. So we can give a column here. So let's give a column here, and the next column, as you can see, this is 15 feet span. So along this, let's give a column here. So 3 columns we have provided, and let's check this span. If you can give a column here, 12 feet span, easily we can give 3 columns along here as well. So we are maintaining the same alignment of the columns here, and along the same alignment we are providing the columns 1 2 3. So this is easy, because we are having the suitable legs, that is usually provide columns between 10 to 16 degrees, 10 to 16 feet intervals. So it is satisfying all the criteria, and it is in the same line and the same alignment, and we are also keeping into consideration the beams which will go. So okay, so this column we have provided, and if I can also draw the beams also, that will also be clear. But let me just assign the columns first, and then we can assign the beams also. So taking a line, let me just show you the beams, because this is one of the main things in the column position, that you must know where the beams will go. Basically, where you have a wall, you will have a beam, that is compulsory. And so this is a balcony part, so one beam will be like this. Okay, I'm just using this color, this line, and I'm using it from here. Okay, so there will be a beam here, and there will also be a beam here along the balcony as well, and obviously along the boundary we'll have the beams. So I'm just using a single line just to denote the beam. There we'll have a beam here, and we'll obviously have a beam here, along which we already provided the column, so we are good here. And there will be obviously a beam here. We don't hope it doesn't go further, because we don't have any walls here. And let's next go with the horizontal ones first. So there will be a horizontal beam here, and another horizontal beam. This one is already been given, so this beam we can extend up to this much, just to have a joining part. And let's go for the vertical ones. This beam doesn't need to be joined fully, but we can actually join this beam up to this much, because this actually we can either have a concealed beam, or we can join it fully, or we can just keep it up to here. So like this we can have, because just to reduce the span of the slab, we can have some concealed beams. You can use some concealed beams like this as well. So up to here we can provide full beams, and this portion we can provide concealed beams. This also, up to this we can provide full beams, and this one we can provide concealed beams, just to reduce the span of the slab. And here I think we'll have, here we'll have another beam like this. So hope all the beams have been covered and nothing is remaining. Okay, these will be some small beams which will have for this puja room as well. This one will extend up to this much. Okay, so I think everything has been covered. So we'll go back to the column positioning. This portion has been done. So now for the next portion, we'll just provide beams here, columns. As you can see, let's take the span which we have into consideration. So like this, we can't provide any columns in between. So we'll just look into the span. This is span of 15 feet 7 inches. So this is span of 15 feet 7 inches, and we can provide columns here. So just provide a column here and provide a column here, 15 feet 7 inches span interval. And after that we can provide a column here. This portion is actually the balcony portion, so it will be after the columns, one here and one here. So if you can look at our theory that we are using the columns between 10 to 14 feet, but here we can't do that, basically because we don't want any columns in the middle portion. So actually this particular column also won't be there, because we can't provide any column in the between. We can provide columns for the staircase. So we have provided one column here and another column. Let's provide this particular column, let's shift it to here. Okay, this particular column will be here. For the staircase one, we'll have another column copied to here and another column copied to here. Just increase the size and copy another column to here. So this, for the staircase portion, we can have this columns. Otherwise, in between we can't have any columns. So that's the consideration we're going to make. And this size, as you can see, it is around 34 feet. So the size of the column will be adjusted accordingly. So I hope now we can discuss about the orientation once the placement of the columns is done. So orientation, we are going to give 1 and 2. So I'm just going to give the orientation here. So it will be, this is orientation 1 and this is orientation 2. If we can write here, this is 1, and hope this is visible. Just increase the size of it, 20, and this is 1 and this is 2. Okay, so I'll write here. So if you just check this span, then definitely this will be your 1. The horizontal dimension will be more. This is 1, and this one will also be definitely 1. This one will also be 1, and here this one will also be 1 here, and this one also will be 1, 1. So here, as you can see, the horizontal dimension is more. So all these orientations will be 1, and the same will be for this one as well. So in this plan, every orientation is 1, but it is the actual example of a plan which of one of our projects. But in different projects, you will have different orientations. We'll come up with more examples and discuss about the orientation from some more live plans which we have made. So we'll discuss about that. Stay tuned to our channel for more videos. If we find comments related to that you want to know more about this topic, we'll definitely make more. So that's all for today's video. Bye bye. Keep learning.